So we had a lot of interest recently about Divicons on the forum. These are Viessmann Divicons, not the prettiest of ones. Certainly the most expensive ones I've come across. These have actually been given quite a few of these actually, and I've been passing them on to customers at lower prices, let's say, to basically to get them used up. I don't like to see anything go to waste, and I don't need a stack of these in my basement, so shifting them out quite quickly. These, even with the main part being free, just buying the bits that go with them from Viessmann, have ended up with them being a little bit more expensive than the other offerings, and I'm not convinced the quality of the Viessmann ones is closely related, correlates with the extra cost. So anyway, not any problems with the other ones, and B Trading are offering us them at quite good prices at the moment, and there's also the other source on eBay for some very good prices, ones you've seen me fit on the other videos. Not seen me fit too many Viessmann ones. Anyway, what is the point of mixing groups? The idea of mixing groups is that we can follow different heating curves on different circuits. So for a heating curve, we will have variable temperature output to a zone based on the relationship between the outside temperature and the desired inside temperature. And if you've got different types of emitters or different types of heat losses on a building, you're going to need the different heat curves set for each of those zones. So that's what this is for. So we've got an underfloor heating Divicon here, and we've got radiator Divicon here. Now there's actually two zones of radiators on this Divicon, and there's actually 3 underfloor heating manifolds on this Divicon. One of the reasons I like this system, just for a bit of thought here, is that one Divicon has replaced the mixing groups and pumps, 3 mixing groups and three pumps, and all the room stats and all the actuators for 3 manifolds. So you could see that on a new install, this would actually be considerably cheaper to do, and considerably more comfortable, and considerably more efficient to do than to use traditional high temperature systems with mixers, fixed temperature mixers and pump sets on the manifold. Obviously, if you're only going to have one manifold, to use one Divicon instead of the pump group and the fixed temperature mixer on a single manifold, the job would be more expensive, but the job would still be vastly better using this system. So, okay, on these units, there are different types, but on the Viessmann ones, we have a little lever underneath here, and you can't see, I haven't got enough light to show you. Could probably just pick it up here. My finger is on a little lever. This lever is almost in the fully closed position, and the one on the underfloor heating system is actually a little bit wider open. And those positions are relevant to the amount of input water needing to be mixed with the return water to give the desired flow temperature on the gauge here. Now we've got quite low loads at the moment, it's about 15 degrees outside, so to maintain comfort levels inside the house, we've got a flow temperature just over 20 degrees for our radiators. That's it's on about 22. We'll have a look at the actual settings in the boiler in a moment. And for the underfloor, interestingly enough, actually I think this gauge is a little bit out. I think it's a little bit inaccurate. I think we're going to find that temperature is a bit lower than that for the underfloor. The underfloor is set for 22, and the radiator circuit is on 17 degrees. So that's why the temperatures are very similar for flows. This is trying to heat the underfloor to get 22 degrees inside the house, and this one is heating the bedrooms or providing enough energy to maintain the bedrooms at 17 degrees when it is when it's 15 degrees outside. We'll check that on the boiler in a moment. So again, so basically the mixing valve operates, it varies the quantity of return water that's mixed with the quantity of new flow water into the flow pipe for each zone, and the 2 different Divicons are following different heat curves. Right, now one of the interesting phenomena is that this distribution header here is going to be running at around 7 degrees warmer than the temperature required for either of these Divicons, and that's actually something that comes up quite regularly. This means that the boiler is actually running 7 degrees warmer, and possibly even more, we'll talk about that in a moment, than it needs to actually satisfy the circuit. So if you didn't have underfloor heating, we only had radiators and it was directly connected, the boiler would have a higher level of efficiency than it would at the moment. But because the flow rate through the underfloor is so high when it's under full demand, we've got to have this distribution header arrangement and glow loss header to hydraulically separate them from the boiler. So the reason for the higher temperature on this is to do with valve authority. So if this was the correct temperature for the highest temperature circuit, which at the moment is the underfloor, this valve would be fully open and this one would be fairly open. We'd need a bigger amount of flow water into each circuit because of its lower temperature. It would be carrying less available energy. And the problem with that is that we would lose authority on the valve. So as the valves open up wider, they're doing less and less control. And really they need to be in a position where they are actually throttling back the water and actually seeing that they're in control. So for that we need this 7 degrees increase across in 7 degrees increase in our distribution header. Okay, so while we've got low loads here, there's a very good chance we're going to have quite a close match between the inlet temperature from the boiler and the low loss header temperature and the distribution header. But if we had really high flow levels in the system, there's a good chance we could have a fair difference between the flow temperature from the boiler to our distribution header temperature. Could be quite a bit higher. So we would then see an uplift of boiler temperature to satisfy the authority on the valves, and an uplift on boiler temperature in order to supply the correct distribution header temperature. So we'd be losing efficiency at the boiler for each of this step. But what we've got to bear in mind is that actually we shouldn't be thinking of it as losing efficiency. It's just the required output of the boiler in order to have the most efficient system. Anything else is going to be less efficient than this system because the boiler is going to naturally run at even higher temperatures. Right, quite a lot to get through. It's quite interesting to look at the pipes, isn't it? 22 millimetre is more than enough to carry our 32 kilowatt output of the boiler at delta T20. And once we get two boilers marrying together, we've stepped up a size here. I think that's actually 35 mil, sorry, on the T's there to carry potentially 64 kilowatts into our distribution header. And of course this is sized for low velocity below 0.5 meters a second, and also to handle the considerable flow rate required for this property for the underfloor heating system. So that's coming back on these returns here, back through the header and back out through our distribution header. Hot water here is quite interesting actually. Sorry, it's a bit of a side tangent, but we've got two pumps running, got two cylinders. I've got a D-strap pump and one sensor. So what's happening here is that when we get the signal for hot water from the sensor, we're using the cylinder loading pump signal to run to open two motorized valves, and the orange wires off the motorized valves to operate the pump, and then we're de-stratting the cylinders via the bronze pump here, so that the one sensor is seeing the temperature of both cylinders, and that's working very, very well. We can actually get full output of the boiler in. These are solar coils, so we've got 4 coils taking up the full output of our boiler here. So, right, settings on the boiler. Right, so here we have heating circuit 2, which is our radiator circuit set to 17. And if we go into heating circuit 3, we can see we've got that set to 22 for the rooms provided by the underfloor heating. Now, they've been used to very high temperatures on the underfloor because the old control system didn't work very well. It was a Vaillant control system and the system hadn't been configured properly and just wasn't working. So they were getting quite high temperatures. So we're going to wean them off of those high temperatures, and I think we'll get down to about 20 eventually on the underfloor heating system. If we go into information here and to general, we can have a look at some of the settings here. So at the moment we have, let's have a little look. output of the boiler at the moment. So thermal output at the moment, remember it's 15 degrees outside, and to heat this it's about 800-900 square meters, so it's a big house. We're requiring 2.6 kilowatts. Now that would suggest that we could do the same job at -1 at around about 12 kilowatts, but it's not quite as it seems, because we put a couple of zone valves in on room stats. There's actually two quite big chunks of the house are actually turned off at the moment, because they don't require the extra heat in there, and we didn't want to achieve the lower temperatures with Divicons, so a little bit confusing. Right, okay, let's have a look at our heating circuit 2. So if we go into here, we can see that we have set temperature 14, so it's actually wanting a flow temperature of 14, and because of the playing around I've been doing with the system, we're at 25, so that valve's going to be fully closed. It's just actually bringing back water hotter on the return than it actually requires now with the new settings I've put in the boiler on the flow. So it's literally going to be doing nothing but circulating water until that cools down, and that's going to be quite interesting. And if we go to heating circuit 3, this is the underfloor heating circuit. Let's see what's going on here. So here we have a set temperature of 27, actual temperature of 28, and we have a current flow temperature of 35, and let's see if I can find the header temperature, low loss header temperature 36. So 35 flow on the boiler, 36 in the header. Quite interestingly, that's a bit of a strange reading. There may be a little discrepancy on the sensors, I guess. And then basically nothing going on in the radiator circuit. We're recycling heat. They're waiting for this to cool down, and we've got a slight input into the underfloor heating circuit. So I hope that helps, and I hope it's not too confusing.